Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning!
We are now on Module 2, Lesson 1, Rational Functions in Real Life. Before we begin, let us first define rational functions. It is a function in the form f of x is equals to p of x all over q of x, where p of x and q of x are polynomial functions and q of x is not a zero function. If you could still recall, polynomial function is a function with non-negative or positive integer exponents. Let us start with number 1. An object is to travel a distance of 10 meters. Express velocity v as a function of travel time t in seconds. Recall that velocity is equal to distance over time. With this, we can now get the rational function of number 1. The velocity as a function of travel time would be v of t is equal to our distance is fixed at 10 meters all over our time is still unknown, so we'll just place t. In creating our table of values, we have here our time, which is t, and our velocity as a function of travel time is v of t. We cannot start with a negative number, obviously because there's no negative time. However, if we will start with 0, remember that our denominator should not be equal to 0 as stated in our definition, and a fraction with a denominator of 0 is undefined. So we'll start with 1. 10 over 1 is 10. Next is 2. 10 divided by 2 is 5. So we will simply substitute here. And next, if we have 3 here, then that would be 10 divided by 3 is 3.33 or 3 1/3. Now you can have additional values of time here, but since it's not stated in the given, then I will just stop here. Number 2. Suppose that c of t is equal to 5t all over t squared plus 1 in milligram per milliliter, represents the concentration of a drug in a patient's bloodstream t hours after the drug was administered. Construct a table of values for c of t for t is equal to 1, 2, 5, 10. Round off answers to 3 decimal places. Use the table to sketch the graph and interpret the results. Now first thing first, our rational function is already given, so we'll just have to copy c of t is equal to 5t all over t squared plus 1. Then, according to the given, we have to construct a table of values for c of t, where our t values are 1, 2, 5, and 10. However, we can start with t equals 0. Since if we will substitute 0 to t, then it won't give us a denominator of 0. In fact, our denominator would be 0 squared plus 1, so we'll still have 1. Therefore, our c of t here is 5 times 0 all over 0 squared plus 1 is still equal to 0. Let's proceed to 1. Again, to get our c of t here, we will simply substitute our value of t in this function. So 5 times our t is 1, all over our t is 1 again, so 1 squared plus 1. So this is 5 divided by 1 squared plus 1 is 2. So we have 5 over 2 or 2.5 in decimal. Next, let's have t equals 2. In that case, we will replace all values of t with 2. So in our numerator, we have 5 times 2 equals 10, and then that is 2 squared, so 4 plus 1, 5. So 10 divided by 5 is 2. Next, t equals 5. we'll be replacing all values of t here with 5. So our numerator is 5 times 5 is 25 all over 5 squared is 25 plus 1, so 26. 25 all over 26 is this one. However, we are instructed to have only 3 decimal places, so we'll have to round off 9, 6, and then that is 2, since the number to its right is 5. Lastly, we have t equals 10. So the same thing, we'll just replace the value of t with 10. So our numerator is 5 times 10 equals 50 all over 10 squared is 100 plus 1, 101. So 50 divided by 101 is this one. However, we have to get only 3 decimal places, so we have to round it off. Our final answer would be 0.49, and we will just copy 5 since the number to its right is 0. Now from our table, we can now graph 0, 0 is this point, 1, 2.5 is this point, and then we have 2, 2 here. We also have 5, and then 0.962, so that's close to 1. So in this portion, so approximately in this point, and lastly we have 10. 0.495 is close to half of 1, so it's here. Then we'll simply connect all of the points to get our graph. Looking at our graph, we can conclude that the maximum drug concentration occurs around 1 hour after the drug has been administered, and after that, it decreases until it is almost 0. We are now on number 3. The distance from Manila to Baguio is around 250 kilometers. Letter A. How long will it take you to get to Baguio if your average speed is 25 kilometers per hour, 40 kilometers per hour, 50 kilometers per hour? Let us start with 25 kilometers per hour. If the distance from Manila to Baguio is fixed at 250 kilometers and you are running a speed of 25 kilometers per hour, that means to say we will simply divide here 250 to 25. That will give us 10. Now the same unit here will be cancelled, so what's left is hours. So it will take us 10 hours to get to Baguio if our average speed is 25 kilometers per hour. Now let's proceed to 40 kilometers per hour. Taking the same distance, we have 250 kilometers, but this time it's all over 40 kilometers per hour. So we'll simply divide 250 by 40, then it will give us 6.25 hours. So it will take us 6.25 hours to get to Baguio if our average speed is 40 kilometers per hour. Next is 50 kilometers per hour. Doing the same thing, we'll simply divide 250 kilometers to this time it's 50 kilometers per hour. That will give us a result of 5. Therefore, it will take us 5 hours to get to Baguio if our average speed is 50 kilometers per hour. Now let's proceed to B. Construct a function t of s where s is the speed of travel that describes the time it takes to drive from Manila to Baguio. Now to get our function t of s, we have to go back to our answers in A. We have here 10 hours, 5 hours, and then 6.25 hours. These are all our travel time when we divided the distance, and the average speed of travel. Now, since our distance is fixed at 250 kilometers, we'll write it here, 250 all over. Our speed could vary, so we'll just have to write S, and this is our function. Now, let us try more examples. Number 1. The budget of a university organization is split evenly among its various committees. If they have a budget of 60,000, letter A, construct a function which would give the amount of money each of the number of committees would receive. To construct the function, we have to identify the variables. Let budget be B and the number of committees be C. Now, budget is dependent on the number of committees. Therefore, our committees here is our independent variable and our B is our dependent variable. So, our function here is the budget in terms of the number of committees. So, our budget will be divided equally to the number of committees that the university organization have. Now, our budget is fixed at 60,000 and we don't know yet the number of committees, so we'll just have to place C. Let's now have B. If the organization has 8 committees, how much would each committee have? So we will be using our function here in letter A. We have 60,000 all over C. Now our C here, or the number of committees, is 8. So we will simply replace C with 8. So 60,000 divided by 8, that will give us 7,500. Therefore, each committee will receive 7,500 pesos each. Number 2. A company has a budget of 90,000 to be evenly distributed among its various offices. The marketing office of the company receives twice the amount of money than the other offices. A. Given N as the number of offices in the company, construct a function which would give the amount of money each of the non-marketing offices would receive. So we have here our function B of N. Again, B is our budget, which is very dependent on the number of offices, which is N. So our function here is the budget in terms of the number of offices. So we will simply divide the budget over the number of offices that a company have. And our budget is fixed at 90,000 and our number of offices is still unknown. Now remember that the marketing offices receives twice, so we'll have to add 1 here in the number of offices. Now let's have B. If the company have 5 offices, how much would each of the non-marketing offices receive? Now we will be using our function in A where our N is 5. So we have here 90,000 divided by 5 plus 1 is 6. That will give us 15,000. So each of the non-marketing offices receive 15,000 pesos each. So here's the breakdown of the budget. The marketing office will receive 30,000 pesos and the rest of the non-marketing offices will receive 15,000 pesos each, a total of 90,000 pesos. That is all for today. Thank you and see you on our next video lesson.
Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning!
For today, we will identify rational equation, inequality, and function. But before that, let us discuss rational expressions. Rational expression is an expression that can be written as a ratio of 2 polynomials. Here are the following examples: 2 over x, 5 over x minus 3, x squared plus 2x plus 3 all over x plus 1. Now the following involves rational expressions: rational equation, rational inequality, and rational function. A rational equation is an equation involving rational expressions. A rational inequality is an inequality involving rational expressions. And a rational function, as you already know from our previous lesson, is a function of the form f of x is equal to p of x all over q of x, where p of x and q of x are polynomial functions and q of x is not a zero function. Here's an example of a rational equation. 2 over x minus 3 over 2x is equal to 1/5. Take note that a rational equation has an equal sign. Here's an example of a rational inequality. 5 over x minus 3 is less than or equal to 2 over x. As you can see, there is a presence of an inequality symbol. So this could also be greater than, less than, or greater than or equal to. Now this is an example of a rational function. F of x is equal to x squared plus 2x plus 3 all over x plus 1. As you can see, the same as rational equation, rational function has also an equal sign. However, you should take note that a rational function has f of x, g of x, h of x, or any other function, or it could also be replaced by y. Now, let's try to identify a rational equation, rational inequality, or rational function. Let us start with number 1. Number 1 is a rational equation. How about number 2? Number 2 is a rational function. Let's proceed to number 3. It is actually none of this. As you can see, there is a presence of a radical symbol. How about number 4? This is a rational inequality. How about number 5? This is a rational equation. How about number 6? Since there is another variable y here, it could also be f of x, therefore, this is a rational function. We are now on number 7. This is a rational equation. How about number 8? Number 8 is none of this, because this is a radical equation. We are now on number 9. What do you think is this? Number 9 is a rational equation. How about number 10? At first glance, it looks like a function. However, if you will look at the numerator, there is a presence of a radical symbol. Therefore, this is none of this. We are now on number 11. What do you think is this? Number 11 is a rational inequality. How about number 12? Number 12 is a rational function. There is a presence of two variables here where y is f of x. That is all for today. Thank you and see you on our next video lesson.
Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning!
In this video, you will learn how to solve rational equations and word problems involving it. We have here x plus 2 all over 8 is equal to 3/4. In this given, we won't be having any restrictions with the answers since our denominators are all constants. Now, since both sides are one rational expression, we can cross multiply. In here, we will multiply the numerator and the denominator is equal to, on the other side, the denominator of our first fraction multiplied to the numerator. So that would be 4 times x is 4x, and then 2 times 4 is 8. And this side, 8 times 3 is equal to 24. Now retain the term with the variable on the left side, so we will transpose 8 to the other side, so that is copy 24. From positive, it will become negative 8. Now copy 4x, which is equal to 24 minus 8 is 16. So divide both sides by 4. So our final answer is 16 divided by 4 is 4. Let us now proceed to number 2. 2x minus 1 all over x plus 3 is equal to 5. As you can see, we have a restriction here. We cannot have a solution of negative 3 because it will make our denominator 0, which is undefined. So to cross multiply this one, let us place 1 as the denominator of 5. And let's begin. 2x minus 1 multiplied to 1. So let us copy that one first, is equal to x plus 3 multiplied to 5. Now, 2x minus 1 multiplied to 1 is just itself. So we will just have to copy is equal to 5 times x is equal to 5x plus 5 times 3 is equal to 15. Now we will place all variables on the left side. So we have here, from positive, it will become negative 5x, copy positive 2x is equal to, from negative 1 to positive 1, and then we will just copy positive 15. We have here negative 5x plus 2x, that will give us negative 3x, and then 1 plus 15 is 16. Now we have to divide both sides by negative 3. So our final answer is x is equal to negative 16 over 3. In number 3, we cannot have a solution of positive 3 here and positive 5 over 2 since it will make our denominators 0. So let us now cross multiply. We have x squared multiplied to 2x minus 5 is equal to quantity x minus 3 multiplied to quantity x plus 2. Let us now distribute x squared. So we have here x squared times 2x is 2x cubed, and then x squared multiplied to negative 5 is negative 5x squared is equal to x times x, that is x squared, x times 2, that is positive 2x, negative 3 times x is negative 3x, negative 3 times 2 is negative 6. Let us just copy the left side, since we can still simplify 2x minus 3x, which is negative x, and then copy negative 6. Since we have x cubed here, we will have to place all of the terms on the left side, and we'll just have 0 on the right side. That would be 2x cubed minus 5x squared. From positive, it will become negative x squared. From negative, it will become positive x. And from negative, it will become positive 6 is equal to 0. Now we can still simplify here the like terms. So we will copy 2x cubed, negative 5x squared minus negative 1x squared. So a total of negative 6x squared. And we will just copy plus x and copy plus 6 is equal to 0. We can now proceed to factoring this out by synthetic division or long division. I will be using synthetic division here. We'll write the constants 2, negative 6, 1, and positive 6. Factoring is a trial and error process. So we have to think of a number here, which is a factor of 6. Let us try positive 3. The first step here is to bring down the first constant, which is 2, and then multiply that to your number, so that would be 6, and place the answer here, and then you add this up. That will be 0. Again, multiplied to 3, place your answer here, and then add again, which is 1. Multiply again to 3, write your answer here, add that 1, that is 9. Now our goal here is to make this last answer 0 to get the factor. But since it is not, that means to say we have to repeat the process until such time this last number is equal to 0. Let us try positive 2. The same process, let us bring down the first constant and then multiply it to our number. 2 times 2 is 4. And then we will add this up. That will give us negative 2. Negative 2 times positive 2 is negative 4. This will give us, when adding, this will give us negative 3. Negative 3 times 2 is negative 6, which is equal to 0. That means to say 2 is one of our answers. Now we will work on with the remaining constants here. So you have 2x squared. So from x cubed here, this will now be x squared. Minus, next to x squared is just x. Negative 2x, and next to x is just a constant. We will factor this out using quadratic formula. Quadratic formula is in the form x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Our a is the constant beside x squared. This will be our b, and this will be our c. So let's start. We have here negative of negative 2 plus or minus the square root of b squared is negative 2 squared minus 4. Our A is 2 and our C is negative 3. All over, our A is positive 2. So x is equal to negative of negative is positive 2 plus or minus square root of negative 2 times negative 2 is positive 4. And then negative 4 times 2 is negative 8 times negative 3 is positive 24. And then all over 2 times 2 is 4. Now we can simplify what's inside the square root. So that is 4 plus 24 is 28. So we have here x is equal to 2 plus or minus square root of 28 is equal to square root of 4 times 7. Now 4 is a perfect square, so we can take it out. So square root of 4 is 2, so what's left is square root of 7 all over 4. Since there is a common factor which is 2, we can divide everything by 2 here. So 4 divided 2 is 2, 2 divided 2 is 1. So our final answer here is 1 plus or minus square root of 7 all over 2. Now we have here our set of x equals 2, and then we have here 1 plus square root of 7 over 2, and the other one is 1 minus square root of 7 all over 2. So these are all our final answers. Let's now proceed to word problems. In an inter-barangay basketball league, the team from Barangay Kuliat has won 12 out of 25 games, a winning percentage of 48%. How many games should they win in a row to improve their winning percentage to 60%? So in here, Barangay Kuliat has won 12 out of 25 games already. If we will divide these two here, it will give us 0.48 or 48%. Now, we have to add up number of games wherein they should win in a row in order to improve their winning percentage. Now, since this number of games is still unknown, we'll just have to place x. So we have 12 plus x all over 25 plus x is equal to 60% is 60 out of 100. Since 60 and 100 can still be simplified, we'll just have to copy whatever is on the left side is equal to, our common factor here is 20, so 60 divided by 20 is 3 and 100 divided by 20 is 5. Now, since there's one rational expression in each side, we can now cross multiply. We will multiply this one here, so that's 5 multiplied to quantity 12 plus x is equal to, we have 3 multiplied to quantity 25 plus x. Let us now distribute 5. 5 times 12 is 60. 5 times x is 5x is equal to, let's distribute 3. 3 times 25 is 75 plus 3 times x is 3x. Now we have to place all variables on the left side. So we'll copy 5x and then from positive to negative 3x. Here we will copy 75 and then from positive to negative 60. Now we have here 5x minus 3x, that is equal to 2x, and 75 minus 60 is 15. Let us continue our solution on this portion. Now let us divide both sides by 2. So our x here is equal to 15 over 2, or that is equal to 7.5. Now, since there's no 7.5 value for games, we will round it off to the nearest whole number, which is 8. Therefore, our final answer here is Barangay Kulyat should win 8 games in a row to improve their winning percentage to 60%. We are now on number 2. You have 6 liters of pineapple juice blend that has 50% pure pineapple juice. How many liters of pure pineapple juice needs to be added to make a juice blend that is 75% pineapple juice? So at first, we have 6 liters of pineapple juice blend where 50% of it, that is 3 liters, is a pure pineapple juice. Now, we have to add a certain number of liters of pure pineapple juice to it in order to increase its concentration. But since this number of liters of pure pineapple juice is still unknown, let us label this one as X. So we will add X to 3 and we will also add X to 6. The result of this will increase the concentration to 75%, which is 75 out of 100. Now, since the right side can still be simplified, we will just copy the left side here. And then our common factor is 25. So 75 divided by 25 is 3 and 100 divided by 25 is 4. Now, since there's only one rational expression in both sides, we can now cross multiply. So this is 4 multiplied to quantity 3 plus x is equal to 3 multiplied to quantity 6 plus x. So we can now distribute 4 times 3 is 12 and 4 times x is 4x is equal to 3 times 6 is 18 plus 3 times x is 3x. Let us now place all terms with variables on the left side. So we have to copy 4x and then from positive it's negative 3x is equal to copy 18, then from positive 12, negative 12. Let us continue our solution on this side. So we have 4x minus 3x, that is x, is equal to 18 minus 12 is 6. Therefore, we need to add 6 liters of pure pineapple juice to make a juice blend that is 75% pineapple juice. That is all for today. Thank you and see you on our next video lesson.
Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning!
In this video, I will teach you how to solve rational inequality. But first, let us recall that 0 divided by a number is equal to 0, while a number divided by 0 is undefined. We have here x minus 1 all over x plus 3 is greater than 0. Since the left side is already one rational expression and the right side is 0, we'll just have to rewrite this one here. Now we will get our critical values. These are cutoff values that define regions to be tested. We can get these values by setting our numerator to 0 and our denominator to 0. In our numerator, we have here transposing negative 1, so it becomes positive 1. While our denominator here is x plus 3 is equal to 0. So transposing 3 from positive, it will become negative 3. These values are what we will be using for our graph. Our graph for inequalities is a line graph. So a line graph is from negative numbers going to positive numbers. This is also like the x-axis of a Cartesian plane. Our first value, negative 3, will make our denominator 0, which will be undefined. Therefore, negative 3 is not part of the solution, hence we will be using a hollow point. Next value is 1. 1 will make our numerator 0, and 0 divided by any number will result to 0. Therefore, 1 is also not a solution because it is stated here, the answer should be greater than 0. Hence, we will still use a hollow point. We are now ready to test our regions. First is copy the given, and we have formed here 3 regions where the cutoff values are negative 3 and positive 1. Let us now test region 1. Think of any point coming from this region. So it could be negative 4, negative 5, negative 6, and so on. For this example, I will be using negative 5. But it's up to you what number you will consider. So negative 5 will be substituted in our given. So negative 5 minus 1, same sign, add. So that's negative 6. And then negative 5 plus 3 is negative 2. Negative divided by negative will result to a positive answer. Next is region 2. Think of a number in between negative 3 and 1. I will be choosing the easiest one, which is 0. So 0 minus 1 is negative 1. All over 0 plus 3 is 3. Negative divided by positive will result to a negative answer. And last region, think of a number on this side, 2, 3, and so on. But for this example, I will be using 3. 3 minus 1 is 2. All over 3 plus 3 is 6. Positive divided by positive will result to a positive answer. Now going back to our given, we are to get the values that are greater than 0. Therefore, we are looking for positive values. So our solution are region 1 and region 3. So we will simply shade region 1 and region 3, and this will be our graph. Therefore, our solution set is x is an element of real number where this portion here, these values of x are less than negative 3, and we'll just place OR, and the x values here are greater than 1. Number 2, 1 over x is less than 1 over x minus 3. As you can see, the right side is not 0, so we have to do something about it first before we begin with our solution. So 1 over x, transposing this rational expression from positive, it will become negative. Copy the inequality symbol, less than 0. Remember that our left side should only have one rational expression. Therefore, we have to perform subtraction on these two rational expressions where our LCD are the denominators x and quantity x minus 3. We will divide the LCD to our denominator and multiply the answer to our numerator. Starting with the first rational expression, divide the LCD to the denominator, x will be cancelled, so what's left is x minus 3 multiplied to 1 is x minus 3. And then, the next rational expression, we have the LCD divided by the denominator. The quantity x minus 3 will be cancelled, so what's left is x times 1. It will result to x. Now, we can still simplify here, x minus x is 0, so what's left is negative 3 all over. We'll just have to copy our LCD and then copy less than 0. We can now proceed on getting our critical values by equating our numerator and denominator to 0. Let us start with the numerator. As you can see, there is no x variable in the numerator, so we'll proceed to the denominator. Our LCD is x times quantity x minus 3, and we will equate it to 0. By zero product property, if the product is 0, then either of the factors or both is equal to 0. So our first critical value here is 0, and the other one is from negative to positive 3. Therefore, we will be using this cutoff values to have our regions to be tested. Our critical value 0 is not part of the solution because it will make our denominator 0, which is undefined. Hence, we will be using a hollow point. Same with 3. This will result to 0, which is also undefined, so we will still use a hollow point. Now we have here 3 regions to test. To do that, let us first copy our given, and our cutoff values are 0 and 3. Let us now get a value from region 1. I will be considering negative 1. So we have here negative 3, and then substitute x with negative 1, so this is negative 1. Negative 1 minus 3 is negative 4 times negative 1, so that is equal to positive 4. Negative divided by positive is negative. Let us now test region 2. So a number from 0 to 3, so we could consider 1. So we have here negative 3 all over. 1 minus 3 is negative 2. Negative 2 times 1 is negative 2. Negative divided by negative is positive. Lastly, region 3. So I would like to consider here 5. Now we have here negative 3 all over. 5 minus 3 here is 2. So 2 times 5 is 10. Negative divided by positive is negative. Now looking at our given, that is less than 0. So we are looking for negative values. Therefore, our solution are region 1 and region 3. In our line graph, we will simply shade region 1 and region 3. Therefore, our solution set here is x is an element of real numbers where our x here is less than 0, or our x on the other region is greater than 3. Number 3. X squared minus x minus 30 all over x minus 1 is greater than or equal to 0. As you can see, the right side is already 0, and then the left side is one rational expression. So we will just have to rewrite this one. Our numerator can still be factored. So we have here x squared is x times x, and then we will think of the factors of negative 30. That is negative 30 times positive 1, or positive 30 times negative 1, or it could also be 5 times negative 6 and negative 5 times 6. Now if we will add up each of these factors, we should get negative 1. So negative 30 plus 1 is negative 29. 30 plus negative 1 is 29. 5 plus negative 6 is negative 1. Therefore, this is the pair that we are looking for. So we'll just have to write here positive 5 and negative 6. So we are now ready to get our critical values. Let's start with n. That is x plus 5 multiplied to quantity x minus 6 is equal to 0. Again, by zero product property, if the product is 0, then either of the factors is equal to 0 or both of them is equal to 0. So we have here x is equal to negative 5, and on the other side, x is equal to, from negative 6, it will become positive 6. Now let's proceed to the denominator. Our denominator is x minus 1. We will have to equate it to 0. So our x here is from negative 1 to positive 1. So we have here negative 5, 6, and 1. So if we have here our line graph, we will write first negative numbers going to 0, going to positive numbers. So we will start with negative 5 and then 1 before 6. Now negative 5 will make our expression 0, but it's here greater than or equal to 0. So it is still accepted as a solution, so we will be using a shaded point. Now our critical value 1 will make our denominator undefined. Therefore, this is not part of the solution, so we will be using a hollow point. Now 6 will also make our entire expression 0, but it's still okay since we are looking for greater than or equal to 0. So we will be using here a shaded point. Now using our given, we will test out these 4 regions wherein our boundaries are negative 5, 1, and 6. So let us now select a value from region 1. I will be considering here negative 6. So we will be substituting negative 6 here. Negative 6 plus 5 is negative 1. Negative 6 minus 6 is negative 12. So negative 12 times negative 1 is positive 12. And then negative 6 minus 1 is negative 7. So positive divided by negative is negative. Now from region 2, I will be considering the easiest, which is 0. So this will be 5 and this will be negative 6. So 5 times negative 6 is negative 30 all over. That is 0 minus negative 1 is negative 1. Negative divided by negative is positive. Now from region 3, I will be considering 2. So 2 plus 5 is 7. 2 minus 6 is negative 4. So 7 times negative 4 is negative 28 all over. 2 minus 1 is 1. Now negative divided by positive is negative. Now for our last region, I will be considering 7. So 7 plus 5 is 12. And then 7 minus 6 is 1. 12 times 1 is 12. All over 7 minus 1 is positive 6. Positive divided by positive is positive. Now going back to our given, we are looking for greater than or equal to 0. So we are looking for positive values. So we have here region 2 and region 4. Therefore, our solution set is x is an element of real numbers where x is in between negative 5 and 1, or our x here is greater than 6. Now as you can see, we have shaded point here, so we will place bar here, and there's no bar in that hollow point, and we will be placing another bar here. So this is our final answer. That is all for today. Thank you and see you on our next video lessons.
Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning!
In this video, you will learn how to graph rational functions. Number 1. F of x is equal to x minus 2 all over x plus 2. Our domain here are all real numbers except those values of x that will make our denominator 0, since it will make our rational expression undefined. So, x exact negative 2. Therefore, our vertical asymptote here is the line x is equal to negative 2. An asymptote is a line that the function may approach but does not reach. Let us now plot our vertical asymptote. Since we already have our domain, let us get our range. To get our range, we have to look at the degree of our polynomial equation in the numerator and denominator. Our highest exponent is the degree of polynomial. In the numerator, we have 1, and in the denominator, we have 1. Therefore, n is equal to m, where n is the degree of the numerator and m the degree of the denominator. If both degrees are equal, we will just divide our leading coefficients. So y is equal to 1 over 1 is equal to 1. Therefore, this is the line of our horizontal asymptote. This is where we will pattern our range. So our range here is y is an element of real numbers such that y is not equal to 1. Let us now get our intercepts. Let us start with our x-intercept. We will be getting our x-intercept if we will let our y be equal to 0. So we have here f of x is equal to y, so that's 0 is equal to x minus 2 all over x plus 2. Now, we can cross multiply this one since the denominator of our 0 is 1. So we have here 0 multiplied to x plus 2 is equal to 0. And then copy the equal sign. 1 multiplied to x minus 2 is just x minus 2. We will be transposing negative 2 to the other side to get the value of x. So we have from negative to positive 2. So we can rewrite this as x is equal to 2. This will be our x-intercept. Now let us proceed on getting our y-intercept. Our y-intercept can be taken if we will let our x be equal to 0. So we have here f of x, or simply y, is equal to 0 minus 2 all over 0 plus 2. So that will be y is equal to negative 2 all over 2. So that is negative 2 divided by 2 is negative 1. This is our y-intercept. Now we can plot our intercepts here as a point. So we have here, if our x is 2, our y is 0. If our y is negative 1, our x is 0. Plotting those points, it is here 2, 0 and 0, negative 1. Now let us decide on the values of x in our table of values. We will make our vertical asymptote as our middle ground. So we can have here these values, negative 5, negative 4, and negative 3. And then to the right side of negative 2, we have negative 1, We cannot anymore consider 0 because there's already a point here. We can consider 1 and 3. So we can now substitute each of our x values here to our given function. But since we can easily do that one using our calculator, I will simply show you the answers. Plotting these points, we have negative 5, 2.3, negative 4, 3, so it's this point, negative 3, 5, so it's beyond here, so this point, and then negative 1, negative 3, this point, and then 1, negative 0.3, so this point here, and then 3, positive 0.2. Now we will use these dots to create the curve of our rational function. So this is now our graph. We are now on number 2. F of x is equal to x minus 5 all over x squared minus 8x plus 12. Let us first factor this out before we proceed with the graphing. X squared is x times x, and then factors of 12 or 12 times 1 will make it both negative since we are looking for a negative middle term. Negative 6 times negative 2, and lastly we have negative 4 times negative 3. Adding these factors, we have negative 13, negative 8, therefore our factors are negative 6 and negative 2. So our domain here, x is an element of real numbers except those values which will make our denominator 0, which are positive 2 and positive 6. Therefore, our vertical asymptotes are x is equal to 2 and x is equal to 6. So we will be plotting our asymptotes here. First is x is equal to 2 and the other one is x is equal to 6. Let us now get our range here. Looking at our degree in the numerator, we have 1 and the degree in our denominator is 2. Therefore, n is lesser than m. In this case, our y is automatically 0. Therefore, our horizontal asymptote is the line y is equal to 0, which our range will be patterned to that. Y is an element of real numbers except 0. So let us plot our horizontal asymptote here. Y is equal to 0. Now let us proceed on getting our intercepts. Again, let's start with the x-intercept, which we can get if we will let our y be equal to 0. So f of x is equal to y, so that's 0. And then copy x minus 5 all over x squared minus 8x plus 12. Now we can cross multiply since our denominator of 0 is 1. We have here, this will give us a product of 0, and then 1 times x minus 5 is x minus 5. So we will get the value of x here by transposing. So negative 5 will become positive 5. So that is x is equal to 5. Now let us get our y-intercept by making our x be equal to 0. So that is y is equal to, our x is 0 minus 5 all over 0 squared is just 0, and then that is also 0 plus 12. So we have here negative 5 all over positive 12. So that is our y-intercept, or in fraction, that is negative 0.5. 41. So our corresponding points here from the intercepts are 5, 0, and then 0, negative 0.41. Plotting these points, we have this 5, 0, and then the other one is 0, negative 0.41. So it's here. Now let us proceed to our table of values. So we have to get 2 points from these regions. So let's start here. So our boundary is 2 and our other boundary is 6. So from this side we have positive 1. We cannot anymore have 0. So let's have negative 1. And then from here we have 3, 4, and then 5 is already in this point. And then 7, 8. Substituting each of our x values here to our function, we will arrive at these answers. So let us now plot these points. We have here negative 1 here and then negative 0.3. So it's just right above negative 0.41. And here 1, negative 0.8. So it's this point. And then we have 3, 0.7. So it's this point. And then 4, 0.3. So just below here. And then we have 7, 0.4. So it's here. And then 8, 0.3, so just a little below here. And then we will connect all of the dots using a curve. Make sure you do not pass the asymptotes. So these are the curves here of our rational function. On this region we have, again, be careful not to touch the asymptotes. And then simply follow the dots. And on this last region, we will just stop with 8. And then let's have the arrowheads. And this is the graph of our function. That is all for today. Thank you and see you on our next video lesson.